Imaginary numbers, Algebra 2, Trigonometry. In simplest form, the square root of negative 300 is equivalent to what? So this is the square root of a negative number, and right there that should kind of throw a red flag up because you can't do that really, at least not until today. Because the square root is saying what times itself is negative 300, and nothing times itself is negative, because a negative times itself is positive. Negative times negative is positive. And a positive times itself is, of course, also positive. So it doesn't make sense to do the square root of a negative number. And so this is where imaginary numbers come in. They're not real, they're imaginary, but they're still numbers, and we need to deal with them. You'll see imaginary numbers in a couple of applications throughout the year, most notably when we get to quadratics, which is later on, probably just a couple days from now. And if our quadratic doesn't cross the axis, the x-axis, then the roots don't exist. Well, then we call them imaginary, and we could still express them with numbers. They're just not real numbers. So it's kind of strange to deal with numbers that aren't real, but that's exactly what we're talking about here. So simplifying a square root of a negative number is really not that much harder than simplifying the square root of a positive number. Like, for example, say we thought of this as just the square root of positive 300. We would think of two numbers, 100 and 3, one of which needs to be a square, and the square root of 100 is 10, so we'd end up with 10 radical 3. Well, for the square root of negative 300, the only difference is that you're going to be left with this I that you see in all these answers, which stands for imaginary. And so instead of thinking of it as 103, think of it as negative 103. The square, use that to be a negative, and instead of 10 rad 3, it's going to be 10I rad 3. And that's why choice C is our answer here. So it's really, simplifying them isn't much harder than simplifying regular radicals. You just, add an I to the coefficient part there. The important formula here is that the square root of negative 1 equals I. And so that's what we're doing, is we're basically taking out a rad negative 1 here, and that's why we're getting I with the 10I rad 3. But simplifying the square root of a negative number is really pretty easy, as long as you think positive numbers are easy. Like this next one, the sum of rad negative 18 and rad negative 72. So rad negative 18, I'm going to use two numbers. Now, again, just think about the 18, that'd be 9 and 2. So we're going to do negative 9 and 2. And this negative 9 is going to give us the 3I rad 2 plus, because we're doing sum. Negative 72 is negative 36 and 2. So, 36 is our square, and so the square root of negative 36 is 6I rad 2. And 3I rad 2 plus 6I rad 2 is 9I rad 2. So again, simplifying negative radicals is, or negative square roots, is really no harder than simplifying positives. You just got to remember to have that I there to represent that this is an imaginary number. The other thing we're going to talk about in this video, other than the square root of negative numbers, is what we call the powers of I. Like we see, what is I to the 10th equivalent to? And we're going to do a lot of calculator stuff here, but let me give you a little bit of background. First, again, the key to all this is we know that the square root of negative 1 we're representing as I. And so the exponents to I. First, we'll start with I to the first. I to the first is I. Anything raised to the first power is itself. I squared, however, that's different. I squared equals negative 1. And that's the most important one, because you're going to see that come up again in a few other things. So always remember I squared is negative 1. And where that comes from really is if we take this up here, remember with radical equations, if we square both sides, well, what happens when you square a square root? You just get the number inside. So that's why it's negative 1 equals I squared. So that's where it comes from. I to the third equals negative I. And that makes sense because I to the first times I to the second equals I to the third. And I to the first is I, and I to the second is negative 1, and negative 1 times I is negative I. And the fourth one, and I'll explain why there's only 4 in a minute, the fourth one is positive 1, because that can be thought of as I squared times I squared is I to the fourth. And I squared is negative 1 times negative 1 is positive 1. So that's that one. And then something interesting happens when we go above 4 is that it just starts to repeat. That I to the 5th is I, and 6 is negative 1, and 7th is negative I, and 8th is 1, and so on, and so on, and so on. And so it just goes around and around in the circle. Any power of I is going to be 1, negative 1, I, or negative I. Those are your only options. So I to the 10th, now again, I mentioned we're going to do a lot of this in our calculator, so let me show you that we can type all of these into our calculator here. Let me just pull out my calculator and clear this. So first, I is when you hit second decimal point, that's how you get the I symbol. And so I to the first is, our calculator tells us I. But if we try I squared, again, second decimal point for I, and then square it, calculator tells us negative 1. And let's try I to the third. We're going to get negative I. And I raised to the fourth. It's positive 1. So, I mean, it's important. It's good to know where this stuff comes from, but your calculator will do all this work for you. So let's try I to the 10th. Let's see if our calculator can do that. And luckily, it can. It tells us it's negative 1. And so the answer is negative 1. The reason why this is the answer, I'm going to tap a pen here. Sorry, my computer is on a little bit of a lag. There we go, catch up. So the reason why it's negative 1 is because we see 1, 2, 3, 4. So 5 is back to here. I to the first is I, and then 6 is the same as I squared, and 7 is the same as I to the third, and 8 is the same as I to the fourth, and 9 is the same as I, and 10 is finally back to I squared. So it just goes round, round, and around these circles here. And wow, my computer is really behind. But anyways, let's go back to our calculator and let's try something other than I to the 10th. What happens if you try something really large? Like let's try I to the 99th. So you raise it to the 99th. What happens? Well, you get this weird answer. And that's not 1, negative 1, I, or negative I. And so what happens is sometimes the calculator gets confused. But we have a short, or I guess a little trick that we can use, that if you go to the math key, and then over to the number folder, which is to the right, you see choice number 3 is I part. Select that. So choice number 3 is I part. And then type in I raised to the 99th. And hit enter. And that tells us it's negative I. So that's what you can do if you're doing a power of I and it doesn't work out. I part is kind of just something that I part actually stands for interval, but it works out for powers of I that this is something that we can use. Now again, you could just go around the circle a whole bunch of times, but I doubt anybody's going to do that. All right, let's look at one more problem. This next one is the value of 2i to the 8th is equivalent to what? Well, the first thing you're going to do with these problems is you're going to type into your calculator 2i to the 8th, hit enter, and if it works, you're great. If it doesn't work, then you have to go to math and try your I part. And so go math over to number, choice 3, and now let's type in 2i to the 8th and see if that'll work for us. And it does. The answer is 2. If it ever doesn't work, the final option you have is to do it in pieces. Remember that this is 2 times I to the 8th, and so I could just figure out what I to the 8th is, and it's a power of 4, so I know it's going to be the same thing as I to the 4th because this goes around in powers of 4. So all the powers of 4 are I to the 1st. And so that's just 2 times 1, and that's 2. But again, the calculator will do the work for you, but it's good to know the background. All right, that's where we're going to stop it.